2011. He returned to Keta Senior High School, his alma mater, to work as a mathematics teacher in the year 2012 after completing his national service. He obtained a Master of Philosophy degree in statistics from University of Ghana in 2014. Then he returned to Ketasco to continue work as a mathematics teacher, promoting an approach to mathematics which places more emphasis on understanding of mathematics concepts rather than only doing calculations. He found his way into Ketasco's National Science and Math Quiz team somewhere in 2017 and played an active role as one of the mathematics trainers for 2 quiz seasons. He moved on to become a guest trainer for other secondary schools. He has authored a book, Thinking Mathematics, to serve as a manual for contestants of the National Math and Science Quiz. Currently, he is a PhD student in the Statistics Department of University of Ghana. He believes that mathematics is a useful, meaningful subject, good for exercising the brain, and is willing to promote the study of the subject at all times. Please, with a round of applause, help me welcome Mr. Deladinam Amekagu.
The head of the mathematics department, colleague teachers, my brothers and sisters, I regard it a profound privilege to be asked to talk to you in this year's Mathematics Week. I've been asked to talk to you about empowering all to succeed in mathematics. I am particularly happy because the person through whom the invitation came was my student. Paul, I'm proud. I am happy you brought me here. So when I received the topic, I started thinking, what will it mean to empower people? Because I know power is something that when politicians have, they start misbehaving. What is supposed to be right, they put it left, and all those kind of things. Is that the kind of thing that we are to give people like you? But I consulted the Cambridge Dictionary, and it told me that to empower someone is to give the person an official authority or the freedom to do something. Now we are empowering all. But when I came here, I saw helping all to succeed. To help also is to make it easier for someone to achieve an aim. So they are all good. Now all means everyone. That to my mind means not leaving anyone out. The next word in our topic is succeed. So again, I tried to find out what it means to succeed. I gathered that to succeed is to achieve a desired aim. So if you set out to do something, you have an aim, you have something you want to achieve. If you put rice on fire, after some time, you want it to be cooked for your consumption. So if whatever you have set out to achieve comes to pass, we can say that you have succeeded. Excuse me to say, if someone decides to kill you and ends up killing you, he has succeeded. The result may not be a positive one, but he has succeeded. So what I want to say is that success is defined by the person engaging in the activity to succeed. Whatever you set out to achieve, getting that is success. Finally, the last word in our topic is mathematics. As a mathematics student, I'm aware that there is no generally definition for the subject. Nevertheless, we can say a few things about the subject. For instance, we can say that mathematics involves calculations. That exercise of manipulating 2 or more numbers to get another result. For instance, you say 2 times 3/6 equals something. That should be 1 or something. When you are doing that, you are calculating, you are evaluating. In fact, to some people, the whole of mathematics is equal to calculations. I do not subscribe to that view anyway, but I agree that the subject is big on calculations. We can also say that mathematics is about looking for unknowns, solving for unknowns. Someone says 2x plus 5 equals 15, and you are working out to find what the value of x is. We do that a lot, don't we? Yes. Mathematics also studies structure, form of objects. We study properties of geometric objects such as lines, circles, cuboids, etc., etc. So if we say that mathematics concerns the study of shapes and their properties, we are right. We can as well say that mathematics is in the business of analyzing data, making statements about population through observed data. That's what statistics, of which I'm a student, is concerned with. We can continue to say a lot of things about the subject. In fact, when you want to define a subject or you want to define anything, you look at the properties that it presents to you, and then you define based upon that. We do not have a generally accepted definition for the subject because even though it is a very developed subject, it is still evolving as we go along. Finer and more specific fields are springing forth. Having said all that, I'll share with you two definitions that people give to math. Some people make it simple. Mathematics is the science of numbers, which I agree to. Because when you look at all what we do, numbers are the most fundamental objects. All the other mathematical objects we deal with are based on numbers. You have number in there. For instance, when you take a vector, the components in there are numbers. So when someone says mathematics is the science of numbers, that's fine. A senior mathematician will simply tell you that mathematics is all that mathematicians do. So then you may be asking, who is a mathematician? Now, he will say that because, like I said before, the subject keeps expanding by the day. So the things that mathematicians do are increasing. And so it is a very careful way of approaching the topic by saying mathematics is all that mathematicians do. So, considering all what I've said about the subject so far, substituting all these explanations back into our topic, which says empowering all to succeed in mathematics, we can now understand our topic for today to mean giving everyone the authority to achieve his desired goal in a subject that people simply call the science of numbers, about which I have said a few things so far. But we have to ask a quick question. What is success to the students who are here? We've already said that to succeed is to achieve your aim. But what is success to the student? What aim? In other words, what aim does the student sitting here have? Will any student help me? Or I help you? I believe that every student here wants to pass his examinations very well. True or false? In fact, I gathered also that your motto is achieving excellence. So every student here wants to achieve excellent results in his examination as far as math is concerned. Do we we agree to that? Okay. If so, then we can go back to state our topic as giving all or giving everyone the authority to attain excellent results in his mathematics examinations. Do we agree to that interpretation of today's topic? Yes. Okay. If we accept that, then I think I'm justified to approach today's topic with a personal touch. I say this because what today's topic is saying is precisely what I've been trying to do over the past 10 years as a maths teacher. I have been trying to empower my students to succeed in the subject. So in a sense, asking me to talk on this topic is just asking me to discuss what I have been doing as a maths teacher. And that's what I'm going to do now. From some of the things I've said about the subject, you realize that the subject, even though it's deep on calculations, is also deep on ideas, concepts. So I begin my campaign to empowering people to succeed in math by one, helping them to understand the nature of the subject. So I want to begin by discussing the nature of the subject. We can say a couple of things about the subject. I see math as a symbolic summary of the things we do in everyday life. For example, when one says x plus 3 equals 5, that's similar to saying I have a certain amount of money that if you give me 3 cedis, I'll end up having 5 cedis. I think it is not strange to pose that problem to your friend, is it? Yes. So it is an abstraction of what we do in everyday life. But it is put in symbols to compress it. And that is one cause of people's trouble. When they say x plus 3 equals 5, instead of simply telling themselves that x over there is just representing some quantity, they get scared and they leave the subject. I don't want that to be our portion in British International School. What we have to do instead is to understand the symbols. It's a highly symbolic language. Math is a highly symbolic language. As you go along, you get more and more symbols. But all those symbols are representing quantities, some unknown quantities. So they shouldn't scare you at all, should they? Good. The subject is highly abstract. But mind you, when we say abstract, that is not an antonym for real. If you say something is abstract, that does not mean it is not real. If you are looking for an antonym for abstract, you can consider something like physical. If something is abstract, it means it's not physical, it's not tangible. But that doesn't mean it's not real. Let me give you an example. Our English teachers will tell us that sadness or happiness is an abstract noun. Don't they? Does that mean that sadness is not real? I mean, you've ever been sad before? When you come to school and you check your result in maths, instead of getting A or B, you have E or something, how do you feel? So when you tell someone you are sad, and he says, I can't see anything on you, which means you are sad, you are lying. Sadness is not tangible, so you are not sad. I guess you'll be mad at the person. Yes. So abstract does not mean not real. So math is full of abstract concepts. That does not mean it's not real. An example of an abstract concept in maths is the concept a number. Numbers are abstract objects. Nevertheless, they are associated with real things. Let me give you an example. If I have one apple here, and I think it's not enough for my brother and I go and bring another apple. When I leave and come back, I expect to see an apple and an apple. How will you refer to the new collection of apples? 2 apples. If I come back and one is no longer there, I have only one, will I be happy? So I believe that when I add 1 to 1, I should have 2. Now, if you ask me to bring 2, it doesn't exist anywhere. 2 is an abstract object, it's not tangible. No matter how good a mathematician I am not going to be able to bring you 2 any day, any time. But I can bring you 2 apples, right? So we use abstract objects to associate with reality. And it is the reality we should be looking at. Is that okay? That's the nature of the subject. I don't mind spending all my time talking about the nature of the subject. A student once said to me in Keta Senior High Technical School, she was in Form 3, close to her exams, when I was preparing it. She said, "Sir, I've never learned the principle of mathematics. I just follow examples and I'm solving. I didn't know that I should look at the principles and that will help me to solve other problems. I just thought when you see this example, then you just go like that." It is a subject full of principles which you have to adhere to. Is that okay? For example, it's a very structured subject, I must say. Consider board maths, for instance. You have expressions in brackets, you have of, you have multiplication, division. You have to do this one, then you do this one, then you do this one. You cannot say, okay, at the end of the day, I'll do this one, so let me start from here. If you go about it that way, you will not succeed. But why are we here this morning? To empower or to... Yes. So I want to tell you that the subject is about principles, which you have to adhere to. And if you understand the principles, it will not be stressful to you to adhere to them. So sometimes, because you don't understand the principle, it's like you are being forced, so you don't adhere to them. So we have to endeavor to understand the principles governing the subject. Now, it is structured. When we want to discuss an issue in the subject, we begin by offering definitions. A definition is a way of explaining to someone what you want to talk about. I'm very keen on this one. I've spent all my life defending the crucial nature of definitions in the subject. I'm saying this because what I've realized teaching for some time is that when you are talking chemistry, biology, physics, people respect definitions. When it comes to my side, people take examples, they start to work. They think definitions are not important. This morning, as I'm in British International, I am putting it forward and I'm defending it that definitions in mathematics are not only important, they are crucial. I put that in the preface of my book. Definitions are crucial. Let me give you an example. When I was growing up as an adolescent, if you tell a young girl that I want to be your friend, the immediate question that most of them will ask you is, what kind of friend? She's asking you that question, waiting for an answer before she even answers you. What is the young lady asking from you? Definition. She wants you to explain the nature of the friendship before she will even accept. So when I'm saying definitions are crucial, I mean that they are the starting point of having a meaningful discussion. Is that okay? So definitions in math are crucial. That's the nature of the subject. Another thing I want to talk about is how we justify statements in math. When you make a proposition, a positive proposition, we justify it by means of a proof. What did I say? Yes. So a proof is a sequence of arguments that you advance to show beyond every conceivable doubt that the statement you have made is valid. Do I have a basis for putting this forward? Yes. As a teacher, when you ask a student to prove something, what they do is they try to give you examples. Who knows about binary operations here? Binary operations. You've not studied that yet. Okay. Oh, all right. But when was the last time you were asked to prove something? Did you prove anything? Yes. What were you asked to prove? What was the supposed answer? Okay, yes. Now, let me clarify something. So in math, we make propositions. A proposition is an unambiguous statement to which we can assign a truth value. A truth value is true or false. So a statement that you make that can be said to be true or false, that is a proposition. Now, at the base of it, some propositions are very basic and they do not require a proof. We call them axioms. And some are postulates. Postulates are starting points of a discussion. Aside those statements, all other statements depending upon them require to be proved to be valid. So we justify a proposition by proof. It is very essential in the subject. It is very essential in the subject. For example, if you are to show that x plus y all squared is equal to x squared plus y squared plus 2xy, you would have to expand that. It is wrong to say let x be 2, let y be 3, and so x plus y is 5, and the square is 25, and then I try to show that the other expression is equal to. That's just an example. In math, examples do not prove propositions. Is that okay? Examples don't prove propositions. You can use an example to support your statement, but you can't use it to prove a proposition. Proof is unique to math. In any other field, including science, we don't speak of proof, we speak of evidence. When a scientist says he's proving something, he is adopting the word proof from the mathematician. He is using proof in a loose sense. An example of a scientific law would be the sun sets from the east, and the sun rises from the east, sets in the west. That is a law in science. You cannot prove it. Even though it's a law, it doesn't have a proof. Do you know why it doesn't have a proof? Scientific laws are summaries of what happens over a long period of time. That's what scientific laws are. Over a very long period of time, what we have seen. What if we wake up tomorrow and it is the other way around? You see, but we are dealing with numbers. They are abstract fixed objects, so we can make statements about them that endures. But when you are studying nature, you can formulate a law based upon what you have observed. The scientist is in the business of observing the world and making statements about it, trying to explain, coming out with theories to explain what he is seeing. That is the work of a scientist. When we say mathematics is a science, we mean it is structured, it is formal. But proof is something that is unique to math. And that is what we use to justify a mathematical proposition. So these are some few thoughts I want to share about the nature of the subject. Having understood the nature of the subject, when we take it to study, how do we go about it? We have established in the beginning that we want to achieve excellent result. That is our resolve. So my model for the student is, when you take a topic to study, first read the introduction. If the author is a good one, his introduction will be devoid of symbols. When you take a good math book, the introduction will be devoid of symbols. It will be in text. So you try to pick up the keywords over there. There may be some definitions. If the author is a serious mathematician, he will begin by offering some definitions. What I find students doing most of the time is that they skip those introductory parts and they jump straight to the examples where the formulae are. Are you with me? Yeah. So I want to discourage that attitude. Read. You might have been told that we don't read mathematics. It is largely true, but in its entirety, it is not a true statement. I'm a math student. I read math. You know, we read, we also solve. See, we read to get meaning in what we are doing. It is not a mindless activity. When I ask you to find the age of someone, and you end up having an equation like x squared equals 16, then when you solve that, you are going to get x equals 4 or minus 4. But because I began by telling you to find the age of someone, your final answer is going to be what? It's going to be what? You got x equals plus or minus 4. But you are looking for the age of someone, so your final answer will be 4. And not negative. Yes. So it is not a mindless activity. It is not something you do just in symbol. It is a conscious effort trying to solve a problem, a real world problem. That is it. If it is like that, then it makes sense to take this treatment, to try to understand it, doesn't it? Yes, it does make sense. So I urge you to read the introduction, take note of the key terms, the definitions in there, and see if you can write what the topic is all about in your own words. See if you can do that in your own words. Then you proceed to look at the formulae in there. I think I have some few minutes to go. You proceed to look at the formulae in there. Now, sometimes, or most of the times, the formulas flow directly from the definition. For example, when we are talking about a parabola, maybe the definition will be, do you do parabola over here? Not yet, all right. So the formula will come out of the definition. So if you didn't pay attention to the introduction, you will not appreciate the formula. If the formula is derived, try to master the derivation. It will help you. If it is not, try to see if you can derive yourself. Sometimes you can't, sometimes you can. If you can't, leave it. Leave it because maybe the tools that you need to derive the formula, you don't have all of them. There may be a property used in the derivation that you are not aware of yet. So in that case, David, you can discuss with your teacher. Then after familiarizing yourself with the formula, then you begin to solve problems. You can write the formula down a number of times, but the best way to get used to the formula is when you apply them in solving problems. If I tell you that the sum of the first n natural numbers is given by n into n plus 1 all over 2, you can write that down in your book. I will encourage you to use an exercise book rather than a Formica board. I mean, I can be challenged anyway, but I'm saying that because when you use a Formica board, you have to be cleaning all the time, and you can't keep record of your progress. It doesn't cost much to buy an exercise book. So when you're using an exercise book, you can be going back to see what you are doing. You'll be spending time cleaning the Formica board all the time, and that will be taking your time. So the best way is to use the formula as you use it. So the formula I've just given, you can write it down a number of times. But when you are using it, then it is better. When you are writing it down, always you are writing n into n plus 1 all over 2, n into n plus 1 all over 2. But if you begin to apply it, let's say, so what is the sum of the first 3 natural numbers? So n there is 3, n plus 1 is 4, so I have 3 multiplying 3 plus 1, that's 4 all over 2. Okay, you take another one, you do that. What will happen in the future is that you are not going to be thinking in terms of n, you are just going to be thinking in terms of what you do. So anytime I want to find the sum of a certain number of natural numbers, I just take the number, then multiply by 1 more than the number, and I divide by 2. It is not the n or the x that you should be keeping in mind, but it is its operationalization. It is what you end up doing. So if you do that a lot of times, you even forget about the symbol, but the action will stick with you, and you will not struggle to be remembering formulae in symbols. Am I making sense to you? So I will encourage you to do that. So you familiarize yourself with the formulae by the things I've said, and then you proceed to solve problems. I'll be done with you soon. You proceed to solve problems. It's not enough to say that I have read all the formulae, I've understood, I've memorized all the formulae, all the principles, so I will not solve problems. Do you know what happens? Sometimes the problems that the topic is applied are not exclusive to the topic. The question you are solving may involve something. You are learning sequences. I don't know if you do that at this stage. Then a question comes that you have to apply your knowledge of number systems. What an odd number is, how the last digit of an even number is itself even. So if you do not solve a lot of questions, you have mastered all that topic all right. But when you go to solve another problem, the problem involves another topic. The topics are intertwined. If you are going to solve a real life problem, you have to employ a lot of ideas within the subject to solve the problem. So if you don't solve a variety of problems, you will go into the exam and you will not succeed. But that is what we want to do, don't we?
Yeah.
Yes. Then let me briefly talk about working with the teachers. So see the teachers as your parents. Develop a cordial relationship with the teachers. If you are going to succeed in math, you have to lose your sense of shame. You have to lose your sense of shame. It is you. It is your success. I began by telling you that success is defined by the individual. Maybe success to someone is getting a B in the subject at the end of the day. Your success is getting an A. So must you be doing the things that other person is doing? No. So if you don't understand, you ask the teacher. You must lose your sense of shame in order to make it. A small shame is better than a big shame. You are in a class of 20, 25 and you are shy to ask questions. If you fail, the whole community where you move from to come to school will know that you have failed because you are writing again. They know that you should have completed by now. That is the shame you should be avoiding, not that small shame of asking in class. If worse come to worse, you are not able to ask in class, please see the teacher after class, talk to the teacher, and trash things out. The teacher by definition is always having the interest to teach. Students, please know that. At no point should you think I'm worrying him. That's why he's here. He is interested to do that. Why do you think I'm here? I'm interested. I said I regard it a privilege to be here. I am also interested to come and talk about the subject. That's what I do. So the teachers are ever ready. Teachers, am I lying? So, and briefly to my colleagues, I'll say we should also see the students as partners in the work. We don't know everything. Some questions help us to develop ourselves. If not in content, then in the methodology. We grow with the students. As we teach the students, we grow with them. So do you know why the teacher is better than you? The questions they are asking, a certain student has asked before. There are many brilliant students who have passed here. So they've asked all those questions, and each time they ask, if he didn't know, he has gone to learn them. So he has become a better person. I refer to myself not as a senior student, but as an elder student. Elderly just is a matter of age, because I've been studying for a long time. So please develop a cordial relationship with the teachers. We will succeed as we hope to. There are a couple of issues, but my time is up for now. I'll reserve them when we get into the Q&A, then I address them. Thank you for having me.
Thank you very much, Mr. Abegabu. Please, we will take some few questions. We'll take some few questions. If you have a question,
what do you mean by stating that scientific laws can change?
Did I quite say that? Well, I alluded to the fact that proof is something for us, we in man. What you do in science is not proof. It is not proof because you cannot show beyond every reasonable doubt that what you are saying is true. And I gave an example. When you say the sun rises from the east and sets in the west, you say that because maybe for billions of years, that is what we have observed. What about tomorrow? So scientists are in the business of giving evidence. Never mind, whatever they call it is evidence. I'm not talking of a restricted situation. Maybe you are doing physics and you have a certain law, maybe gravitation, that is packaged as a mathematical formula. That becomes a mathematical expression. You can prove that. But let's take biology for instance. I don't tell you that they don't rule anything out. If always this drug works to cure malaria, or these are the symptoms of malaria, and someone comes with another symptom, it is unusual to malaria. You can say that to a large extent, you can't be suffering from malaria and have this, but you can't say, as a doctor, you can't say with 100% certainty that it's not malaria. Even viruses, they are evolving into other breeds. The COVID that we had, as they were working on it, other variants kept coming. You see why a scientist can't prove, you can be working towards evidence. So I didn't quite say scientific laws can change, but maybe I alluded to that. No problem. Are you okay with my explanation? Yes. So proof is a scientific tool. It's a mathematical tool. Proof is it's for us.
All right. Any other question?
Please ask.
Any other question?
There is a hand here. Oh, you are only stretching. Please feel free.
Is there a number?
Yes, 0 is a number. What is a number? A number is an idea used in quantifying collections of objects or properties. That's what a number is. I wrote a book called The Real Number System in 2019. So that's how I might have it. 0 is a number. We use it to quantify collections of objects. If I ask, how many goats are in this room? Goats. As we are here now, how many goats are here? Or what is the number of goats that are here? Yeah. So naturally, allow me to expand this more. Naturally, we began the number system as responding to problems of counting. Counting is the most fundamental mathematical activity. That is why the counting numbers or the natural numbers, which we say over here, are the most basic set of numbers. But we realized not long ago that counting is not only mathematical activity. You are trying to quantify. If I say how many girls are here, you begin counting. But how many goats are here? It's a valid question. It's a real life question which can be posed. But the natural numbers don't have an answer to it. So we brought in 0. And then we have the whole number system. We developed that until we got to the real number system, which we are using now. 0 is a number. It is a whole number. It is an integer. It is a rational number. It is a real number. And it is a complex number. Because every real number is a complex number.
Okay. Yolanda.
Sorry, but you said that 0 is a number and numbers represent quantities, but 0 necessarily doesn't represent a specific quantity. There's nothing, so there's no quantity.
Yes, numbers are used in quantifying. I said numbers are used in quantifying collections of objects or properties. Now, in math, we say a set is a collection of objects. Sometimes our definitions don't point so well to what we mean. That's a problem we have. For example, you know that a set is a well-defined collection of objects of the same kind. So if it's a collection, then we start thinking of 2 or more objects. But have you heard about a singleton? Have you heard about a unit set before?
They do it in year 11.
Okay, they are not there yet. Yes. So listen. So a number is a concept. So the quantity doesn't necessarily have to exist. We use 0 to quantify non-existent objects. That's specifically what we do. So it's a concept. A concept is an idea, a notion. The use is that it is a valid question to ask. How many goats are here? And we need an answer to that. And so we have to devise a word or a symbol to respond to. That's the most important point.
Thank you. Any other? I'm taking last one.
What is a complex number?
What is a complex number? If I'm allowed to respond to it, I will. Because as I was talking, I know that you haven't covered a number of things, but I'm ready to respond to it. Okay, so a complex number is any number which can be expressed in the form A plus BI, where A and B are real numbers, and I, which we call the imaginary unit, is given as square root of -1. So in other words, a complex number is any number which can be expressed in the form a real number plus a real number times the square root of -1. My 20 seconds is up. I spoke with the person before I came, and one thing that came up is what people would do after reading maths, what maths can do for them. But because my time was used, that's why I didn't talk about it. If it is so crucial I talk about it, I will. Otherwise, thank you.
Thank you very much, Mr. Amega. But please, I come out for him as he takes his seat. Thank you very much, sir.
Before I sit down, permit me to introduce my book to you. I know you have prescribed books to use, all the same. Since we are talking about empowering all to succeed in mathematics, I do not really teach in the classroom to empower people because I can't be everywhere. So one of the things I do to empower people is writing, speaking on my WhatsApp status, addressing people on social media in text and all this. I wrote this book to serve as a manual for the contestants of the National Science and Maths Quiz. It is called Thinking Mathematics. Thank you.
Thank you very much. Yeah, so if you are interested in a book, you can see me or see Mr. Paul, and we'll write your name and we will get you.